and such like. Well, it's not going to happen with the DX convention, and still quite a number of other things as well, as Phil will tell you. And that's on 15th and 16th of May. You have to pre-register if you want to take part in that. So that looks as though it's going to be interesting. Other things on the DX front, M0ZMS, Matthew, he's going to be sent down to the RAF station at the Falkland Islands and use the call sign VP8ZMS. And he'll be able to operate the Royal Air Force amateur radio station Club Shack from late April to late August. So if you want Falklands confirming and you've not managed to get a QSL card out of Bob, there's another chance. So that's why I found it's been interesting this evening.
Okie doke. Many thanks. And just to reinforce what Peter said, on the 18th, the intention is to cover opening up the clubhouse and members' opinions on how to move forward with that and how to manage sessions. So that will be a fairly key meeting for us. I did see a post. Someone said, I think it was Steve, was asking what was happening about opening up on the WARC channel. So that's the intention of that. Okay. Anyone else got anything? Anyone get anything else they want to announce?
All QRP members, GQRP Club, you'll probably see the email regarding the QRP convention this year, early September. They're actually canvassing to see how many people would like to attend.
Okie doke. Tristan, anything else from Berry?
I'm trying to get a talk on the Nano VNA, like a real basic guide from what's it called? Alan W2AW, I think it is. He's a big YouTuber. It's getting a bit difficult because the timing of it. So that's something to look forward to as well. And also Rob Sherwood, you know, from the other week. We're hoping to have him on to do a talk for us as well.
Well, if you want something on the Nano VNA, if we can twist James's arm, he and I did an evening on the Nano VNA about 6 months ago. So if Warrington Club members would forgive us, we could always redo that one.
It would be nice to see something on doing a firmware upgrade on the Nano VNA as well.
Can't help you there. I write VNA software based on the N2PK rather than the Nano VNA, but James has got the Nano. I think Steve has as well. Oh, what was that, James?
I think we actually recorded that talk, didn't we?
Did we? I'm not sure we did.
I thought we recorded it second time using Zoom. Ah,
maybe you recorded it in that case.
Yeah, what we're after really is something for idiots who.
All right, they are idiots.
Who have
by idiots? You're right.
Who bought one and don't have a clue what to do with it. So well, there are several members of our club who have gone out and bought them.
Well, what we did last time was we explained how VNAs work and what you can use them for, and then had a practical demonstration of using one.
That's the big version, Christian.
No, it's not. It's just close to the camera. But I've configured mine with SWR plots for 20 meters. It's just that simple.
Oh, well, we'll have a think about that. If you like, James, if you like, Tristan, we could always see about dusting that one off and updating it with a bit more material.
Okay. Assuming
James is up for it.
I suppose so.
You're a gentleman and a scholar. Okay, in that case, without further ado, let's make a start. What we have this evening is a sort of show and tell three-parter on the microBitX. And the first part is an introduction to the device itself and what you can do with it and how it works. Then I was going to talk about measurements, and then Peter's going to talk about sort of mods and how you can sort of extend it and take it on. At least I hope that's what's going to happen. In which case, Steve, the floor is yours.
Okay, thank you. Right, now if I can just I could just get hold of the, you know, sharing the, I don't know.
You should be able to, your co-host.
Yeah, if only I knew how. Start share, there you go. Must be that one, right? And we'll try that. And then I'll try that. No. Right, here we go. Well, it's a this particular one I built is a uBitX 6, which I think is the latest one. I'm not sure, but I think so. And what it is, that's all it is, an HF kit, transceiver kit. It's 10 watts at the lower bands and 5 at the upper 30 meg area from uBitX. It's the only specifications I could find on their website was that it's a dual IF design using 45 meg and 11 meg. And they're claiming this is pretty inaccurate, but they're saying 0.1 microvolts, you can hear it. You can audibly resolve it. But I presume Dave will give us much more detail on, you know, signal to noise ratios, etc. later. Huh. Right, design rationale. Well, if you consider, you know, if you just got a simple receiver, then it's got a need for a lot of gain, because especially if you're coming from 0.1 microvolts, if you want to be able to hear that, that's going to be, well, a lot, quite a few million. And so the only possible way you can do it, because of instability, if you're trying to put a gain of 10 million on an amplifier at those frequencies, is you can narrow the bandwidth right down. And it becomes obvious it's very, very difficult to do this in a simple design. So what's done is super heterodyne. Now I appreciate I might well be talking to the you know, converted here. Super heterodyning is very, very common, and it's even done in the very latest things like Pluto, although the IF there is 0, but it's still basically the same sort of thing. You mix in a frequency and you get a couple of others out, but you can select which one you want, and that's it. And it was interesting to read, though. This is actually a Frenchman, Lucien Levy, who in 1917 had a patent awarded for the idea, and not Armstrong, as the Americans claim. But I'm not going to start a fight. Right, and the point about the superhet is that if you amplify the IF, then that could, of course, see feedback within its own loop, but not right at the front end. And of course, the second IF allows you even better capability. Now, I think I'm switching. Yeah. Oh well, this is the point about all this. It's modern devices, really. They're using a modern device which has 3 outputs, or well, this particular one has 3, but it's easy to set up a different frequency on each output, so you can get your 2 intermediate frequencies correct. And indeed, the way this particular one works to get the upper and lower sideband is to switch the IF to be mixed either with the upper or lower part of the first IF. But you can read all about that on their website, because he does actually do a pretty good detail of the design rationale. Just there, if you can see it. Anyway, no, you can't. Stupid. I'll show you in a moment. Don't do this to me. Ah, right. Back in the room. How on earth do I stop screening? Stop sharing there. Right. Now I'll just show you on the. If it gives me, no, not on the camera. Try that one. Ah, right. So this is my particular version of it, and you know, the only mod I've done on it really is to put fabric in these louver holes to prevent rubbish getting into the into the inside. This is the block diagram. Well, it's not quite the block diagram of this one, because it implies there's a variable filter on the front end, which there isn't. There is a 30 meg filter, but it's not. It's just 0 to 30 meg. And this has two IFs. So I thought I'd not bother with that. We go to a simpler version, which is this one, which is a single IF. And the whole idea is you mix it with the local signal with a mixer, and you get outputs. So you have to select which one you're going to do, but you can then apply gain and filter. And his reason for using 45 meg as the first stage IF was that the 45 meg filters are readily available. So-called roofing filters that basically just bandpass things, readily available because they were used in televisions quite a lot. And so that's not a bad idea. This is, of course, what the mixer does. And not very clear, is it? But you end up with two signals. If you see the bottom two red peaks, and so you can choose really from that, if you're smart about it, you can choose upper or lower sideband. But I would urge you to read the details that he provides on his website and on the whatever HF signals. Right, so that, I'm afraid, was about as far as I was going to go. So can we, are we ready to switch over to someone else?
Yeah, sure. I think that's probably
okay. If you could do the your gain setting stuff, or not sensitivity, that's it.
Let me just share my screen. Bring this up. Go into slideshow. Okay, can everyone see that? Yep. So this was Mike, VSS, having finished getting his microBitX working and then repairing it and modifying it and correcting it again. Kindly lent it to me for a few days so I could have a little bit of a play with his. So what I did was looked at the receive sensitivity, the receive filter frequency setting, the receive linearity, image rejection, curiously the attenuator functionality, which is a bit weird, and the main crystal filter, the narrowband SSB filter. On the transmit side, the TX output power, TX harmonics, and second tone intermod distortion. I didn't have chance to do IP3 measurements because I realized, having borrowed his microBitX, they've actually only got one SIGGEN here. So that will have to follow at some other point. I did look at linearity as a second best though. So receive sensitivity. The problem with all of these things is that this is basically noise. And the problem with noise is it's noisy. And you can't really believe what you read unless you average things for an awfully long time. So what I did was to measure it two different ways and compare the two just to make sure that I wasn't fooling myself in somehow. So if you've not done receive sensitivity measurements before, it's pretty easy to do. The two methods that I used here, which I'll go through, were first of all to generate a known signal from a SIGGEN, put that into the receiver, take the receive audio out of the receiver, bung that into the PC, and then use a well-known program called Spectrum Lab to directly measure the signal to noise ratio. And you can basically, all you do is adjust the signal level until you get 10 dB signal to noise ratio. And then that tells you the noise floor is 10 dB less than that. The second way I did it is that about 15 years ago, we had a Warrington Club project to produce a calibrated noise source. And there's probably still about sort of 8 or 9 of us in the club have got those noise heads. And if you've got a calibrated noise source, then you can directly measure noise figure just by connecting it to the input, connect the output to the analysis program, and switch the noise source on and off. Don't need a SIGGEN. So I did it both ways and then compared the outputs just to see what I got. So here's an example of the first one, which is using a SIGGEN. So the top left-hand picture shows an input signal from the SIGGEN of 28, or just under 29 megs, with a signal level of minus 111 dBm. And what you do with Spectrum Lab, if you've not come across it, it's a great program for mucking around with RF signals or audio representations of signals. And you can tell it to make a measurement every 1 second, 2 seconds, 5 seconds. And in this case, if you look at the bottom here, the equation that it's being asked to do is print the peak amplitude, which it finds, well, to look for a peak amplitude between 2000 and 4000 hertz. So if you look between 2000 and 4000, here is a suspicious peak, it's the SIGGEN. Subtract 34 from that, that magic number is 10 log 10 the receive bandwidth. So that is a magic well-known figure for an SSB filter. And if you want to try calculating what that is, you'll find you get around about 34. And then you subtract from that the normalized noise between those two. And Spectrum Lab will then tell you the normalized 1 hertz bandwidth noise that it detects between those two. And what you get is a printout like that that tells you the signal to noise ratio of that signal in that receive noise. So with 111 dBm of input signal, what that means is that the received noise floor here is minus 121 dBs. And that is an equivalent on 1.8 megs, showing you the a similar plot. An interesting thing we'll come back to later is consider where this is centered. This is the audio going into the PC, 0 hertz, 1 kilohertz, 2 kilohertz, 3 kilohertz, 4 kilohertz. Come back to that one a bit later. But this is the other way you can tell Spectrum Lab to measure signal to noise ratio, is that you can program one of these buttons. And what we programmed it to do is print the string SNR equals plus a string, which is basically formatted as dB. And again, this magic formula, the peak amplitude between those two, minus 34, minus the normalized noise. And in this case, the button here tells you the signal to noise ratio. So that's giving 6 dBs at minus 109 dBm. Word of caution, you will notice that these things are talking about 10.304 dBs of signal to noise ratio. Don't believe a word it says. It's about 10 dBs. This is spurious accuracy in the extreme. The other thing that's interesting when looking at the microBitX is that you get lots and lots and lots of little spurious signals. So this is actually the SIGGEN input, and this is a spurious signal. Those spurii all over the place will completely confuse the program. So you have to tune off a little bit and find a clear space before you try and measure a microBitX receiver's receive sensitivity. And in this case, that 29 meg sprog was bigger than the signal. That's why on that first plot, I didn't measure at 29 megs exactly. I measured a few kilohertz low. And specifically, I moved down 2 kilohertz, and you'll notice now it's an awful lot cleaner. The other way of measuring it is with a calibrated noise source. This was the one that we did for the Warrington Radio Club project. And there's a companion program that goes with it. And what the program allows you to do is, because it's calibrated, all you need to do is tell the program the frequency you're operating at, and it then calculates the ENR, the equivalent noise of the noise head. And then you can switch off the noise source and tell it to measure, and switch on the noise source and tell it to measure, and it tells you the noise figure. It's as simple as that. So we have 2 ways of measuring the noise, and that's what we get. So I think, Steve, you said it's specified 0.1 microvolt.
Yeah, about minus 127, yeah.
Right. What I found on mics, and bear in mind this is mics, so all bets are off, is on 1.8 megs all the way down to, oh, sorry, that 39 should be 29. This was the input I needed to give it for a 10 dB signal to noise ratio. -104 down to about -114 was its most sensitive mid-band. And that corresponds to that as an input level in microvolts. That means the noise figure from the signal to noise ratio is 26 dBs down to about 19 dBs. And measuring the noise figure with the noise source gave figures of 25 dBs to 19 dBs. So they're pretty darn close. I would normally say these are so suspiciously close that I wouldn't believe the results, because when you're measuring noise, nothing ever turns out that good. But what this means is that for a 10 dB signal to noise ratio, that's what you'd hear. The noise floor is going to be about 10 dBs less than that, so varying from -114 to -124. So I think to hear a -127, which is 3 dBs below the noise floor, is pushing it a little bit, shall we say. Either that or Mike needs to take a twiddling tool and a soldering iron to his microBitX. This is, of course, measurements on just one microBitX. It's entirely possible that a different one would give different results. Okay, remember what I said about look at that filter center frequency? What you can see here is that what Mike's is doing is it seems to be passing audio from 1500 hertz to 4 kilohertz, whereas you normally have expected this to be a little lower in frequency. Which seemed a bit strange to me, and it probably is just a calibration or a configurable offset in the code. There is an IF offset on the microBitX 6. This is actually with the setting to center, but you can adjust it either way. So it's probably a case of a little tweak is needed to that mic. Linearity was interesting. As I said, I didn't have a second SIGGEN, so I didn't do IP3. But what I did do was basically measure the output for a given input across its range. And it's pretty good, to be honest. It's linear over about 90 dBs. So it's not bad at all. What about that 30 meg low pass filter that Steve mentioned? The image that it's rejecting is quite high because it's a 45 meg IF. It's correspondingly high in frequency. And the IFs are about 80 dBs down, which is not bad at all. And the image frequency also tells us the IF frequency. With a SIGGEN on 29.001, you get a received tone of 3100 hertz, which tells you the received center frequency. With the SIGGEN on 119, I was getting at 2900 hertz. So the 45 meg center frequency is actually 16 kilohertz high at 45016. I'm assuming that that doesn't matter for the width of the roofing filter, Steve. But of course, it could be just me misinterpreting the results, but I don't think so. The attenuator is a bit weird. There's a built-in attenuator, which is a front panel adjustment from an arbitrary setting of 0 to an arbitrary setting of 250. Surprisingly, it only varies the attenuation by about 12.5, 13 dBs. So I wouldn't bother too much with the attenuator on a microBitX. Just leave it set at whatever you want. It's not going to make much difference at all. Okay, the other thing I noticed about the attenuator was that as I was stepping through every 10 making measurements, when I got to 140, this big spurious signal appeared, which wasn't there at 130. It wasn't again there at 150, or higher and lower than that. It was just on that one setting. Now, why it would be that it does that, I have absolutely no clue. Okay, remember that receive offset? Well, that receive offset offered a simple way to measure the crystal filter in situ. I thought Mike would probably kill me if I ripped his rig apart and measured the crystal filter directly. So what I did do was to adjust the IF offset and adjust the input level signal to give a specific level of audio output in the passband. and this is what I measured as the attenuation. Please ignore this glitch here. That's quite possibly measurement error, or it might be some passband ripple. But the attenuation's pretty good, to be honest, for that crystal filter. I didn't measure it beyond there, but to be honest, it's pretty good, pretty darn reasonable. Okay, on to the transmit side. So this is the transmit output on 20 meters on CW, producing about 6 watts. Its second harmonic is more than 50 dBs down, and if I want to see the third harmonic, I'd need a better analyzer. Unfortunately, my Marconi analyzer is not working, so this was an old homebrew analyzer from many years ago, and there were no close-in spuriae visible at all, which is quite good. And as Steve said, the power varies. It goes down on the higher bands. It actually went down quite a lot on mics. So I was getting 12 watts output on top band, all the way down to 2.5 watts on 10 meters. The way this was measured was just simply bunging an oscilloscope on the output of a 30 dB attenuator, and measuring the size of the carrier. That 12.5 watts on top band gives a bit of a problem. Hello, Vincent. Would you like to mute? Many thanks. So this was basically the powers that I saw, and that 12.5 watts and 1.8 megs did actually give a problem. Oops. And the problem is that is the fundamental coming out on 1.8 megs. There's the second harmonic, which is about 16 dBs down. There's the third harmonic, which is about 6-7 dBs down. There's the fourth harmonic. There's the fifth harmonic. That is too high a power setting for the MicroBit X6. I don't know if it's configurable in software, Mike, but that one probably needs tweaking down a little bit. When you go up to 80 meters, it's pretty good. 3.5 megs and 5 megs showed no harmonics greater than -60. The third harmonic on 7 megs was about -45. On 10 megs, the third harmonic's -47, and the fifth harmonic's -49, and it's similar results on other bands. So if you're going to bung it into a big amplifier, make sure there's a big filter. Close in, the spectrum is really quite clean. That's the signal on CW, and this is just on an SDR receiver. This is two-tone SSB on 500 milliwatts, and it's starting to show some some significant third-order products, and that's only 500 milliwatts. That's 1 watt, and that's 2 watts. So unless you're an Italian, I wouldn't drive this at high power into an amplifier. It's going to spread far too much. So in summary, before passing the floor across to Peter, I thought that was not a bad little rig. Its receive sensitivity and its linearity are good. There's something not quite right about the calibration, the setting of the passband of the IF filters, which probably could do with a little bit of a tweak. But the one thing I would note is the transmit linearity is all right for a low power rig, but please don't put one into a big amplifier unless you back the output right down. And I saw a post on social media just the other week of someone who was building a 400 watt amp for his MicroBit X6. I hope it's a bit more linear than Mike's is. And be careful of low frequency operation, because the output power there, certainly on this one, was way too high and needs turning down. But the big caveat emptor is this is one set of measurements, and I did rather twist Mike's arm to let me borrow it just as he finished getting it working again. So it could well be that I'm doing it a disservice here. And apologies, I didn't have a chance to measure the receive IP3. Okay, that's all from me. And Peter, may I pass the floor to you?
Yes, indeed. Thanks, Dave. Now let's see. Just the first great challenge is to get it up and running. I think we've got it here. Yeah, go to slideshow. Everyone seeing that?
Yeah.
Okay, fine. Yeah, right. Thanks, Dave. Yeah. Start with just a little a slight apology to Warrington Club members to some extent, because this is information on one of the original microBitX kits from at least, I think I built this one in about 2018. But at the last, when it was suggested that we do a feature on the version 6 to the last committee, our chairman suddenly said to me, "Oh, I completely forgot you did that." So, so you're all suffering it again with many modifications. So that's what I'm going to look at now. As I say, it's an older version, so the specification can be is like to be a little bit different. So I'm just going to do an overview and look at some of the what I found, my thoughts of it, and what I thought were limitations and things that might be changeable, and indeed have a bit of fun with it. So these are my sort of thoughts at the time. Back then, it was very much a homebrew sort of item. Here, it's indeed completed board, fully aligned board with came in a box with the various peripheral components ready to be soldered onto it. But alignment did indeed become a question, as I'll refer to a bit later. Then looking at, I'll talk a little bit about the homebrew approach to it. Then improvements and modifications came very much to mind. As Dave said, not a bad rig at all, not bad certainly for the money, and it does work. I've had QSOs on it quite favourably. And the two things that I really focused on from there were AGC and some sort of automatic gain control, of which there was none at the time. The one I have, and then the software was quite basic at that stage. I know it's moved on quite a bit at this stage, but I thought let's look at what different software we can put on it and jazz it up a bit, if anything, make it a bit more functional. And at the end of this time, construction methods are always something I like to mention. So that's just an overview. That's an aerial view of the one I did a couple of years ago. Hello.
Okay.
Hello.
Sorry, carry on, Peter.
Can I be heard?
Yeah.
Okay. Yeah, that's the one done by me. The only I thought I'd just mention on this slide. That's how simple it is, really. The whole board comes complete, and you simply fashion up some sort of case. As I think they just about produce a case for it, but I've gone down this very simple homebrew approach of that is an MDF base with a front and back aluminium panel bolted on, which gives you a dead solid, nice square case every time. So I use that, and it's very, very flexible. And as you'll see, I've pulled that apart and put it back together several times in the interim. So more on construction things later. So what were my thoughts? The things I'm going to just go through now. Firstly, let's call them problems or observations at this stage. The audio was extremely thin, sharp, jumped about all over the place, partly because of having no AGC, but I also found it to be less than correctly aligned. Simple process though, just the details to do in alignment were given given with the spiel, and a very careful follow through of that improved it somewhat. Next one down, limited functionality. The software at that stage was indeed very simple. Single line display, so on and so on, and lots of press buttons and not very many facilities for using what you might call a modern, a rig of this day, and indeed no AGC. So what were the solutions we did to that? I just mentioned by realignment, we made the audio acceptable. I knew it wasn't right because even just looking at examples on YouTube, of which there are many, many indeed, they generally sounded quite good, and I think I got it nearer to that point. So AGC problem, what do we do there? I actually fitted, it was on the slide before, but we'll have a close look. I fitted a third-party AGC board. There aren't many things you can do on this this fully constructed board, but that is one that can be shoehorned in there with a bit of maybe use a bit of care, sort of thing. And software-wise, to increase the functionality, I dug out some research and dug out some third-party software, which at that stage was quite quite an uplift to what was in use before, or supplied by HF Signals. This is the thin audio that I mentioned. It was nothing like what you might typically hear from a commercial SSB transceiver set at about 2.4 or thereabouts, and I knew it could be improved. So I also, what I did do, I took a step too far. I did change the audio output chip to an LM386. I actually forget what is in there now, but you can piggyback it. It's on a DIL socket, and by a bit of careful twisting of wires and moving pins to different sockets, you can make that thing work. And so we had to go with that to not much effect. So the cure was thankfully more. I jumped the gun a bit. The cure was to do a careful realignment, and got it somewhat acceptable. So on to the second one on the list, which is functionality. Incidentally, the title of all these slides is at the bottom, which is a quirky thing I decided to do. So this is the limited functionality. So what can we do about that? As you can see in the early versions, it has a single line display. It doesn't tell you much at all. It gives you, I think it told you the mode, which VFO you were on, and what frequency you're on, of what frequency VFO A was on. So that was it. And generally the software is quite limited in its comprehensiveness at this stage, due to albeit I'm being very bold in saying it had a very simple Arduino sketch at that stage. I'm no writer of sketches, so I should not be too critical in that way. But it was fairly basic, and so that's something I wanted to look at and how could we improve it. For example, it was push button to change the band, push the button again to change the mode, and keep working laboriously working your way through that. Now I know they've changed that on the current kit, and the one I've got here I think is quite eloquent in that respect. So as I say, no QoS weighing through. Again, to get to change bands, you had to wind up and down to the various frequency you wanted, and so on and so on. Things that you would expect to be improved on a much more, up-to-date, very usable rig. So let's just tackle the various things we mentioned there. The various observation. Design doesn't include AGC. I'll stand to be corrected, Steve, if the new one does. I really don't know. I can see it shaking your head. So that's fine. Yeah. This manifests itself. We've always looked at simple rigs, I'm sure, in the past, and it manifests itself in drastic changes in audio levels, and particularly, for instance, if you want to try with a CW, especially with earphones on and so on, it can be quite alarming at times. So, having read many stuff on the internet and on the forums and so on, some people are making a board to help solve this problem. And so solution was, as I've said, a third-party solution. BIC is an add-on board by whoever. I put the question marks because there were several available at that time. The one I've gone for, the one that I've just sort of stepped through now, is by Kit Projects, who are a firm from they're a USA company. Quite $20, slightly over $20, I think. Got it. I believe it was out of stock when I ordered it. Had to get on the waiting list, but got one in 2 or 3 weeks, and went on to fit that. And as this is a very practical sort of little explanation of what I've done, just take you through one or two, just the basic steps. Certainly not beyond anyone with a a fine tip soldering iron. This is the board. I do have a better picture, I think, coming up of it. The instructions are 2 pages long, and so not quite the beginner's thing, but and incidentally, not a lot on the technicality of its function, but plenty on just the practical side of getting it into the rig. So that is the board as it comes. It's 1, 2, 4, 5, 6, 7, about 10 connections to be made in a very small space. The top 2 connections is the RF line in and out, and the rest of it is obviously controlling positive and negative over to the right, and then we're connecting up to the gain control and so on. The bottom picture is simply telling us that the only other thing that comes with this board is that 2-pole 2-way switch, and that's the connection to that. So you do have front panel control of off, fast and slow AGC, and it has been worth the effort of getting it on board. Only obviously an evening's work to do it. This is the scaling picture, as we do sometimes, to show you it's against a new pound coin. Now that's the size of the item, all surface mount, of course. And this little jumper here is where they supply it, but you can actually put a preset pot on there, or indeed take it out to a panel and get some alteration in RF gain. Although I haven't actually done that, so can't really comment on the improvement it might give you. Now here's another quite crude photograph taken straight off the RF Kit Project's installation page. That line, the top line, we've got the 3 circles here. This is actually connecting the board into circuit. And the middle one, though, you have to dig into the board, dig in and actually break the trace at that point there, very carefully, of course. And then it allows you to connect this RF line comes in there, comes out there, and goes on its merry way. And here, as I said, is ground and positive. And if you just seeing the next slide is the better one to show it. Yeah, I think this is it fitted in my in my board. Picture is not the best in the world because this pink wire is going straight over one of the connections. But again, that's the top trace line, a fairly ropey soldered joint on both sides of that, but it's working. And virtually, if you get that in place, if you get that joint, that connection right, and push it up against this the surface mount capacitor there, push it up against that, everything else falls into place. And so it's not, it's be the size of a postage stamp, it can be fitted fairly easily. So we've got ourselves an AGC in place now. So does it work? How has it been a significant improvement? We'll maybe just see if we can actually listen to it from there.
From the same band, that's impossible because you're just transmitting into another radio. But you can blow the front end by being on a similar band. Like for example, 80 and 40 with a harmonic.
Right, so that's just the state of the rig at that stage. The modification being the AGC, and I would just say the audio is very, very nice indeed. But I will admit it's not from an internal speaker; that's from an external speaker, which makes it go quite well. The other thing to mention while we're on that slide, of course, is there's the display. I know it's the photography is very bad at that stage, the lighting's bad, but that's a single line display, and that's all that's available to you at that point. So we then move on to the other thing I wanted to cover fairly quickly: software changes that could improve functionality and give it a better display, something a bit more colourful, a bit more up to date. I'm sure all this information is indeed still on the web, but station KD8CEC did some marvellous things to it round about the time I'd done mine. those two things being to improve the software from the Arduino side. So the Arduino sketch he developed is much more comprehensive than the original. Although still, it's still a single line display, he may have got more information onto it there with a couple of lines. So it was somewhat better, made the rig much more usable. But then the thing that really gave it a bit of razzmatazz and more functionality is the other thing he did. He developed software to put a Nextion screen on the front, and if nothing else, this gives a better operating experience. The rig that's sold now, I know the one that Steve has done and Mike has done, does have that thing, but I don't think it's the same software. So let's just take a further look. This maybe is telling most of the people on the meeting tonight how to suck eggs, I suppose. But there are two sections to the software. It's in the Arduino environment. They call HF Signals call it the Raduino, which is an Arduino Nano with a board on it, a board on the back of it. And to make that improvement, you simply need to download some sketch and upload it to the Arduino Nano, or the Raduino as they call it. It's as simple as that, really. Download his code. The nice thing about downloading his code, I found, from someone who plays about with these things without enough knowledge, is that by God it worked without any problem at all. We just put the thing, as I say, downloaded it and uploaded it to the Arduino, and it worked with vast improvement. I've had so many little experiences of using someone else's code, and you get glitches, and you spend more time sorting that out than, as it were, enjoying the thing you wanted. So connect it to the physical process, connect to the Arduino through your PC in the Arduino IDE, set to Nano, and press the upload, and the result, a comprehensive two-line display now with many more functions than the original. So big help, and I know people were using it like that much of the time. But then the shortfall is still there in terms of being a friendly rig, and one that you enjoy to use. So still limited display information. So what do we do? What can we do about that? The solution is to go onto a Nextion screen. You're probably all familiar with Nextion screens. They use so much for all sorts of applications in what we do these days. Many different sizes. And I couldn't resist putting in brackets there. They all have different code. Because I do recall when I downloaded the stuff into Xloader, I got a screen full. I got a desktop full of different versions of the software and you had to plow through and get the one you want, which wasn't too much of a process. The process here is it was quite fun, really, a little bit heart in mouth, but fun. That's why I did. I couldn't resist putting it down like this in a sequence. You download into the software that facilitates this is Xloader, which is a facility to put data into a micro SD card, which is how the Nextion screen is loaded. So you download Xloader, get that on your PC, download KD8CEC's firmware stroke software into that. All sound like a mouthful, easier to do than talk about, quite honestly. With the rig switched on, this is interesting. With the rig switched on, upload the Arduino code to the Nano, Nano, in the uBitX, in the microBitX. You copy the Nextion file from Xloader onto the SD card. The SD card goes in the. You need a little copier to do that. Put that in the Nextion screen, and with it all live, I think this is great at the time. With the front off the rig, you simply unplug the old display, unplug the Nextion on, and you have a working screen with much more functionality. The data is automatically copied to the Nextion display at that point. It is important then to switch it off and take the and it stresses quite low. You take the card out of the display there, because apparently if you don't do that, when you switch off, it'll all disappear, and you've got to go through the process once again. But then you power up to a different animal, as far as I was concerned. Quite good. Just to give a little flavour of what that looks like. This is how I approached it. This is the beauty of this sort of homebrew approach. Simply unscrew the front panel here, and pull off this unplug this original display. I've actually got the next gen screwed into the steel panel there, and next stage is with all the lights on, you plug the next gen into these 4 sockets here from the original thing, and you get this display here, which is rather more interesting. You would I think you would agree. And there's a bit of a close-up of it. I think the current microBitX has got pretty much all this this functionality on the front panel now. But we've got we can toggle VFO A to B. We've got band up and down switches, mode, continual presses of that will change through all the usual modes. We can lock the thing. We've got VFO and A and B showing on the front panel. This is the tuning step. This is all the current status of CW, from the tone to the key speed, the type of key you've got. This is the attenuator that Dave mentioned before. It's not, even though it ain't very good, it's got a nice little facility to move it on the front. And you've also got the IF shift here, which does have some functionality. So what we've got now is we've got a rig where we don't really need to keep digging into right back into the menu to make simple changes. I just put that one on there. That was HF Signals marketing picture at the time I was doing this, when they just brought out the case and moved it to this, and that was their solution to the front panel at the time. I really don't know if that's exactly the same, but that's what I'm using as a result of my changes, and that was the commercial version at that stage. So moving just finally on to a few more things about home brewing and the fun you can have with doing it yourself. That's how it was looking at that stage, and it stayed like that for quite some time. I thought I might get that to, oh yeah, there we are. Not that it's makes any difference really. Just to get a close-up of it there, get it closer to it. There again, once again on 80 meters. It seems to perform very well on 80 meters, as Dave pointed out, and I think I find that quite good. Other things I've just done there that the original kit didn't have. I've now got, love to have little LEDs knocking about, so we've got a little green LED when we switch on. Move the microphone up to a 4-pin, so you've got proper push-to-talk on the, without having to resort to other methods. Over here is now the AGC control. So still in very homebrew state. See, here is the oblong hole we started with. Because it's your homebrew, you can hack it about any way you want. So we changed that to a bigger hole to put this to get this thing in. So construction-wise, I think I've actually commented on the approach. The MDF base, which I think gives a good solid thing to work from. Front to back paddles that you can knock about. I'm now going to wrap around a lid on it, and it's easily modifiable with these screw-on, screw-off panels. So what further mods? I don't know if the one that Mike and Steve have done has now got all the data interfaces in it. Steve's nodding. Yeah, that's something that's a stretch beyond where mine's going to go. So that's again, that brings it into the 21st century, you might say. Now here's the other one. An auto ATU would be a good thing, and maybe some audio filtering. So that reminded me, when speaking about auto ATUs, again, I know that Steve has done this, Mike has done it, several other people in the club have done it, and so do I. We built this thing here, which is an auto ATU that covers the same sort of frequency coverage as the rig. This is an eBay item for 20 odd quid, and works quite well. And of course, clearly there's room inside this box to to put that to you if you so wished. And now I haven't gone ahead and done that, but it's clear, for having a bit more fun, you could get yourself that and get your power and SDR readout on the front panel and all of that sort of thing. So, and I didn't mention audio filtering. Finally, that's my finished rig, or as finished as any homebrew thing ever is. It can, can pull it apart and do something else to it anytime we want. But now I just turn the panel black. We've just got audio gain, proper mic socket. I think you'd agree, quite a lot of information on the front panel now, and a working AGC on this side. So, in conclusion, why is it a good project to do? Why bother with it? It is not a commercial rig by any means. It has its limitations. Or could I just go back to that? Because this box on the right, just give that a little shout out. That is a audio filtering unit along with digital noise reduction, and it really cleans this thing up in terms of some other of the shortcomings. So another, that's a Cumbria Kits item actually. I think it's well and truly defunct now, but great shame because they made some very good products in their in the day. So finally, why did we do it? I think it was a good blend of analog and digital. Steve explained it is basically still a superhet rig, double conversion, but it goes into the digital age with the control of it generally. It's hackable within an extent, to an extent. It's one board basic design, so that limits its hackability. But as I've shown, you can do one or two things. The software development's been great, so that's made it a bit of a difference. And of course, there's nothing like doing something homebrew. And whether it's, I think, no matter how many times you've done, how experienced you are, when you switch something on, it works. It's just great stuff. So thanks for listening, and back to you, Dave. Hello.
I just realised I was on mute. Sorry about that. Yeah, thanks very much, Peter. Yeah, I'm guessing that the AGC is still the same on the BitX 6, Steve, from the way I did those linearity tests.
I presume it is. I don't know, honestly.
So probably still needs your modification board, Peter. Any comments, any questions from anyone?
I found that very, very good. Because I've just built today the version 4.
Right, version 4. Right, yeah.
Yeah, same as yours, and it's right at the very early stage where it's got the 1.9 LCD thing.
That's right. Yeah, yeah.
So
that's exactly the same thing. Yeah, yeah.
Yeah, it's an easy thing to do, isn't it? All you got to do is put it in a case.
Absolutely, it's a semi-kit, isn't it? It's not going to take. It doesn't take long at all. But I thought I had quite a lot of fun in messing around with the software and getting it to, getting the new display onto it. And I'm thinking if I can do it, anybody can do it, as it were. So I feel that moved it on quite a bit. Yeah.
Yeah.
When you were talking about the audio, Peter, I was wondering whether or not it's actually the same as I found looking at mics, in that the actual offset of the IF is a bit high.
Yeah, yeah, and I think that, I think, and it sounded that way, Dave. It sounded like that sort of problem when you're in IF shift or whatever. So thankfully, but again, the proof of the pudding is it is okay, really. So it's a good, quite a fun product. Yeah.
Yeah, and you can just manually adjust the IF shift down to compensate for that anyway.
You can indeed, with the software it is. Yeah.
I found that fascinating, Peter. It's very enjoyable. Clearly, it's very enjoyable when the person got a great deal of pleasure out of making it. Does that use the SI5371 or whatever it is with the 3 VFOs in it?
I think it does. Yes.
I think Steve.
Steve. Yeah.
That's better than me, but go on, Steve.
That's the one, SI5351A. There you go.
That's the one I was thinking of. With 3 VFOs like that, how do they achieve a high degree of isolation between them.
You don't want them to be isolated, do you? You want the things to move together. If you're doing a you want both IFs to go, don't you, at the same time? I don't know. I would have thought so. The mixes be, otherwise it won't get through,
Hang on,
you need to link together. I know that you only need two, of course. That particular one has 3 outputs. I don't think he's using the third one.
Because I was thinking of using that same synthesizer to supply the major VFO part of it, and the changing frequency from the first IF to the second IF, plus the demodulator, which you would want to, I would want to switch between upper and lower sideband. So you've got a lot of frequencies there that need to be independent. And I would worry about the second oscillator. If that gets into the power lines, somewhere or other down the line, that's going to mix together with the VFO, I think.
Well, that's always a possibility. I appreciate what you're saying, but that's that's part of the design, isn't it? To try and minimize that. You can control all these signals, these frequencies, very easily with software. So it's you don't trim it. Don't trim things with resistors anymore. But
Oh, no. Yeah.
I think there is a certain amount of leakage of oscillators going on, Jack. What I found was that in trying to measure the sensitivity, I was trying to search for places near the frequency as I was measuring where there weren't spurious products in order to get a clean measurement.
Well, I was going to say that measuring down at such low levels as you were, I would be utterly amazed if there weren't all these sproggies. And at the price, it's almost worth having 3 separate chips if that enables you to get rid of the sprogs.
Yeah, what I don't know is whether or not any sort of additional screening internally would make any difference. I mean, I didn't go tuning around a lot. I mean, I've not used it. Peter and Steve and Mike are probably better to comment on this than I am, but all of the sprogs I found were quite low level ones.
Yeah. I'm probably worrying about nothing, but that's just me.
I suppose it's a testament to the board layout and design in the first place that it's reasonably well, it doesn't suffer from any big spuria. I mean, Mike, what did you find tuning around with yours?
Right. The small amount of time I had to play with the thing, I'm afraid, was on the software front. I tried 3 or 4 different versions of software to get it to where it was, and I think that some of the sproggies are probably introduced by the Nexian display, because I've read recently that there's an onboard regulator close to the display, and then they're reckoning that some more bypass capacitors put around that area helps no end with that. So I wasn't surprised that 1 or 2 sproggies sort of reared their heads. But all in all, I think it's a cracking radio. I've used it on receive quite a lot and compared it with radios costing a lot more, and it does seem to hear most things. So I think it's great for the money.
Yeah, I'd agree with you there. I mean, the sensitivity is very good. I mean, a noise figure of sort of 15 to 25 dBs when using it on the HF bands is perfectly adequate. Any more than that, you just be reducing the dynamic range.
I haven't seen the Nexian display before. I think I came across it, but I didn't study it. It looks extremely good compared to the standard one they supply, I must admit. Lot better. I can see why you changed, Mike.
How much was it?
What, the display or the whole rig?
No, the display. It's certainly made a big difference to the appearance. Just curious as to how much it cost.
They were about the size. There's the whole range of these things, Jack. At the time I did mine about a year ago, that one was about, I think, about 12 to 15 pounds, something like that.
It was money well spent.
It gives it a different, puts it in a different league. Yes, really. Yeah.
Yeah, it's easy, as Peter was pointing out. It's quite easy to put different sizes of these things in as well, and the software by that American chap has settings for all the different sizes of display, so it's easy to do. I have these things because I have quite a lot of these hotspots that we use for digital radio. So it was just a matter of hooking one of them out and trying to shoehorn it into the same space that the original display.
I only ask because I always feel that the essence of good design is there's one part to another. Nothing should eat up all the budget to the expense of everything else. And I can see a hand creeping round the door, Mike. You might be interested. You know, the display shouldn't cost 10 times as much as all the other goodies.
I found the most difficult part of my build was cutting out the thing for the display itself. You know, the bezel. How did everyone manage with that?
I think the main one there would have been Peter, because the other two kits are built for that size display, weren't they?
Well, of course, mine is a homebrew case. I never bought the case at all, you know. So just get in there with the hacksaw and have some fun, sort of thing. So yeah, and that's the beauty of, as I did it, you know, an easily demountable front panel that you can put on the bench and drill more holes into it, change the holes, and or make a new one once you've got it the way you want. So yeah, that's a part of the fun, certainly.
I find that trying to cut a rectangular hole, it helps a great deal if you've got a couple of pieces of steel which you use to define the edge that you want to file to, rather than file to a line.
I cheated when it came to the display on the Auto ATU. I stuck it on the outside of the case rather than the inside, so the hole didn't matter too much.
Yeah.
Yeah, and I tried to get a Nextion display on mine to actually fit the hole, the original hole. So unfortunately, the two screw holes there, I'm going to have to etch the board a little bit with a drill to find those two holes. But at the moment, it stays and it works. So
yeah.
Unless you use Albert's trick and use a hot glue gun, Mike.
It's very good at the moment, because you can the two screws that hold the original board is fine, and it doesn't impair the touchscreen functionality at all. It's quite stable, but could do with those two screw holes filling in somewhere.
Any other comments or questions?
In terms of ordering it, did you have to pay VAT when you ordered it because it comes from India? And did you get clobbered with any of the other weird Brexit taxes?
Yeah, you get done about 40 quid, I think. Can't do much about it though, can you? It's coming in, and it's bound to get declared. Although, didn't somebody say if you can get them to post it to you rather than a courier, it may, I'm sure, it's Tristan, wasn't it? I think.
Right.
Yeah, ages ago now. Yeah, if you can get them to post it to you, it'll get to you for nothing. But I'm afraid it cost me about 40 quid extra, I think.
Yeah, I've got a few pictures that I can share with of my build today, if anyone's interested.
Yeah, go on.
Yeah, okay. I'll it's on my here we go. Let me try and do this again. So this is me cutting out the the bezel of. Can you see that? Yeah.
Mm-hmm.
Okay. So I'm using a scroll saw to do it, and scroll saws are great for doing scrolly shapes, but they're not great for straight lines, unfortunately. So, and that's the reason I bought the thing, to do straight lines, and it's not very good. It's good for doing jigsaws. And then this is the when I started off, I just put it in the actual plastic enclosure, and then I suddenly thought, oh, it's got no shielding because it's plastic. So I then lined it with self-adhesive aluminium screening tape, and then I made sure I overlapped the edges, so when it all pieces together, it's all screened. And here's another view of it. And by that point, I put the bezel in, and this is me just screening the back. So so yeah, there we are. And
thank
there
you.
it is. And it took a long time to cut out the aluminium from the slats as well.
You cut those, did you?
No. It's already in the case, but I covered it with aluminium, and then I removed the aluminium to give ventilation, and my speakers on the side. So there we go.
Yeah, I think as Steve pointed out, that having a speaker on the top is a recipe for things falling in, isn't it, Steve?
Yeah, I'd say so. Yeah.
Yeah, and I've added an LED cutout there, but it's not actually wired up to anything. But I know it'll come in handy for something. So yeah.
Okay, anything else from anyone? In which case, Steve, Peter, many thanks for that, and thank you, Tristan, for sharing where you were on your build as well. At which point I'll say we'll close the presentation part and just turn it over to general chit chat if anyone wants to share anything.